So in the last video, we had a quick look at the Node.js and the MongoDB side of things. Not too in depth, but I will post the code and examples along with the videos. But right now, we just saw essentially the Node.js application working on its own natively, just from the command line, essentially. Nothing to do with Docker. But as we've sort of mentioned, the idea is this is quite a simple example. So you could just publish that Node.js application and off you go. You could host it on a server, web, cloud hosting or whatever it might be. But if you want to, the problem with that is if you miss environment variables or settings or something that works locally on your machine but doesn't work when you deploy it, then that's where Docker can come in quite nicely, because if it works within the Docker container locally, it will work wherever you deploy that Docker container. So that's what we're going to do in this video. Again, if we look at our Docker file, which is in the root directory, and again, this can be for, it's not really specific to Node, obviously, Node.js. It can be Java, .NET Core, whatever language, whatever platform you want to use, ultimately. But again, very quickly, we've got our base image. So that's the one that we've downloaded. So we'll just have a quick look. And at the moment, I've got a couple of other images, but we'll not worry about those. And I'll come back to the ones that are running on Azure. That'll be in the next video. But you can see there we've got Node, and then there we go. And there's the tag, which is like the version 980 Alpine. So that's there. Okay. We're doing all the rest of it. It's going to run. Copy the stuff into the container and run it, essentially. So the way that we do that, again, in the last video, we just did Node and then index.js, or I was using a utility called NodeMon, which will run the Node application. But that's just running it locally. But to run it in the container, we're essentially going to build, which is sort of compiling all of this together. So we're actually going to do a Docker build. So if I have a look in my command line, okay, so the steps that we're going to do is build another image, because we've got the base image. But what we're going to do is we're going to take that base image, copy our Node.js application into it, and that in itself will create another image. So we've used the base image as a template, then we're copying our application in, and we can optionally give it a tag, i.e. version, and we can then build containers, runnable containers from those images. So it's quite handy. You can have one release of your application in an image, then you can have another image that's got an updated version, and you can then generate containers when you need them from those base images or those images that you've created. So that's what we're going to start with. So we've got our Docker file, which is hiding there, and the way we do this is, I should have this on my there we go. Yeah, so we do a command called docker build, which is essentially saying, go look at this because I'm in that directory. Okay, and the Docker file is at the root of that directory. Okay, you can see there. Yep. And docker build will actually look for the Docker file and then literally go through and compile your request for the Docker container. Well, actually, sorry, Docker image first. So this is building an image first. So I'm just going to call this instead of awesome tube, I'll do awesome app image v1 maybe, or something like that. But it is an image that we're building first, but it's going to use, like I said, the base Node 980 Alpine image and pop our sort of application in and create that. So that's the tag. We're giving it the -t there is going to create a tag, and the space dot means just build it from this directory, essentially the context. So if I click enter there, or press enter even, you can see it's building the image, and it's done a few things there, and it's hopefully working correctly. So it hasn't created a container as such at the moment. If we have a look, if I just clear that so we can have a fresh view, if I look at the Docker images now, you can see I've got a new image now, okay, and there's our tag basically. Well, actually, strictly not true. The name is awesome. The tag is latest. Now we can modify that to say, you know, alpha 1, beta 2, whatever it might be. So I do apologise, I probably gave you the wrong terminology there. But that's basically given us an image that we can use, but it's different to this one because this one now, our awesome app image, has literally got our application in there as well. So the Node application that we looked at in the previous video. Okay, so if I just have a quick look at the containers, so docker ps-a, we can still see I've got a couple of containers. They're not running, and I can just verify those. Look, there's the names there. If I have a look in Kitematic, you can see there's the containers there. They're not running at the moment, but they exist. So you can start and stop containers. Okay, but right now, let me show you what we can do to run the container. Sorry, create a container, a runnable container from that image. Okay, so as you can see, we've got the image built. Okay, and it's essentially compiled. Okay, so I can now do, in fact, I think I've already got it here somewhere, and there it is. Yeah, so what I'm going to do is do a docker run, and I think we've called excuse me, docker run awesome app image v1. Now the -d is just detached, so if I didn't have the -d, when I press enter here, it will be it'll lock the console, you know, it'll be waiting. So by doing that, it'll just it'll create the container, and you can see there, look, it's created a new container that's running. It gave me the ID of the container back, but ultimately it's let me get back to the command line essentially. So if I do ps now, look at the containers, you can see there it is. So there's the container ID, and that's the name that Docker has just given to it. So that's what matches there. Okay, so that is now running, and it's running at the moment in localhost. It's still, well, the IP address of because I'm running this Docker container locally. So theoretically, I should go back to my Postman. I still have localhost, and because it's still port 80, I can still access this. So if I click send, you can see there I've got no response. Okay, now that's interesting. Let's have a look at that. We've exposed port 80 still. So let me have a look at that. API running on localhost port 80. Now I think that's because we've been explicit with the port name there. So let me just try that. Nope. Have I got that correct? Localhost clients, get all clients. Right, okay, this is good. I suppose a bit of troubleshooting while we're actually here. So if I look at settings in Kitematic, let me just double check. There is actually hostname and ports, and you can see there it's actually Docker port 80, but it hasn't exposed it. That's because I think in the Docker file I should have had 80:80. Okay, so there I've obviously removed that. If I did that and rebuild the image and then run the container from that, that should technically work. But let's do, because Kitematic lets us look at the container, it lets us do this in real time, which is quite handy. So let's do port 80 and click save, and you can see it's updating the container and essentially rerunning it. Yeah, there we go. So we definitely have the Docker port 80 and the external port that we can connect to. So if I have a look there now and go back to Postman, I don't need the port 80. I thought it might have been just something I'd done, and click send. There we go, we've got the data. So I suppose in some ways it's good to see, you know, an error in the work so you can actually see how we can fix it. But yeah, I realized expose 80 is the container port internally, and that's the port that we wanted to map outside. So theoretically, you know, that might be like that, but I'm not going to touch that at the moment to save breaking the demo. But you can see we're still able to operate with the sort of API, and from this perspective, it's still localhost. It looks like as if we'd run it sort of just manually through the node application, but of course we're not. We're actually running it via the container. So that's the interesting thing. So I can just to prove that, you can see there we've got some logging out in the container logs. That's why Kitematic, it's pretty handy, to be honest. I mean, yes, you can do all this from the command line, but sometimes, you know, just to be able to look at this visually. And incidentally, while we're here, settings, you can see you might have environment variables that you want to pass into the container when it runs. So from the command line, when you run, you can actually pass a parameter like -e or -e, and then the environment variable name and the value. So you can dynamically pass values in, but again, we'll get into that in a later video. The same thing with, as I mentioned, volumes. You can have volumes that the container allows you to access from your, like a shared drive really. So you can obviously, rather than having to rebuild the Docker container, the image, you know, you can actually have a volume that is there and waiting. So if you're in a dev mode, you know, that you don't want to necessarily be building this every time that you just make one simple change. You could map to where your, say, client application is or something like that, and it'll copy that. You can copy those changes in while the container's running. But again, we'll get to that in the next video. But right now, this is just showing that we've built an image from a base image, basically copied our application into it, create a new image with a certain version. Like I could then create another version. I might have done a change, and I can create another image, like version 2, for instance, and then create a container from that version 2 as well. And I can have these containers multiply, you know, they can all run alongside each other, which is brilliant. But right now I can delete the container. I can stop it. You know, there is a way of stopping it, and you can do that from the command line, which is literally docker stop start. We'll have a look at those commands later. Or from Kitematic, I can simply come in here and click stop, and you can see it's stopping the container. Okay, and that just literally is like just putting your VM on pause, but in this case it's the application container. So I still have the container, but it isn't running. So if I try a quick look now, that isn't going to work because there's no endpoint running now. Okay, but what it allows me to do is restart this. I can literally restart, or in this case start, or I could simply just get rid of the container, because the container it's built from the image. I'm not deleting the image yet, only the container. So the container was created when I did a docker run command. So that's very quick to spin up another instance of the container. So right now I'm just going to click remove here, go back to my console here. If I do if I can spell today, Docker images, you can see I've still got the image there. Okay, but if I now look even on the command line, look at the list of containers, you can see I've only got those 2 containers, which matches what we're seeing in the visual side in Kitematic. Okay, so that is a very quick look at getting the container running locally, and again I could theoretically just repeat what we did, run, you know, run another instance of a container. It would probably give it a different sort of Docker name, but I can spin these up, or indeed I can make a change to my underlying application and generate another using the Docker build, I could create version 2. And I would then have 2 images that I can build containers from. So the image is again like a template, but it allows me to literally roll back and switch between different versions of my application, which is pretty cool. And as you'll see in the next video, when you've got it all running locally, this is a very simple example, so that there's not really a great deal going on. But if you've got lots of other bits and pieces, you've got other environment things that you're working with locally, it basically means that the container can then be literally shipped, you know, to whatever server, like a cloud-hosted Docker container, or you know, your internal server running Docker. It can just run the containers, and it can run lots of containers. So you can have lots of versions. Again, different sort of OSs in those containers, different frameworks, applications, whatever it might be. But we'll get to the next video, which again, we're running this locally now. We're now going to use essentially, we're going to go into Azure, and where we store the images at the moment, the examples that we've used so far have been, the images are essentially stored locally. So again, if I just have a quick look there, and let me just clear the screen. Docker images. There's our images are all local. Okay, at the moment that we've been playing with. But as you can see, this will give a bit of a giveaway. Is you can also have a repository essentially in a cloud, like a cloud hosted environment. I'm using Azure, could be AWS, Google Cloud Computer, whatever, or other hosting companies. So this is actually using an Azure container registry, and that's what we'll go through in the next the next video, along with when we've got an image in the registry on Azure, we can then create a container instance. So where we did Docker run from that image, we'll be able to do that through Azure and have it running essentially that container in the cloud.